The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to this webinar, Uddeholm High Performance Solution. Join Rocco Severino for a unique perspective on die casting solutions as we explore the benefits of Uddeholm High Performance Solution and discuss a complete solution option to improve operational efficiencies as well as achieve targets with Uddeholm tool steel and voestalpine technologies. As he describes it, in many ways, we can assist die casters in achieving their targets and main levers, avoiding scrap, improved machine uptime, and OEE, overall equipment effectiveness. Our goal is not only to be a service provider, but rather to become a valuable technology partner in the die casting industry. My name is Ulf Weisen, and I am marketing manager for voestalpine High Performance Metals in North America, a moderator for this webinar. But first, let's make sure that you can hear us. So we have some instructions for you. You should see this console on the right side of your screen. So I would like you to just type in your first name and location so we know that you can hear us. And you can ask questions throughout the webinar. If you need to minimize the console, you can click on the button there on top, the orange button, and you type it in. So we have some guests here from Wisconsin, right, Canada. Wow, okay. We have from, Spain, Europe. Good afternoon to you. And all right, so I think that works fine. This will be, there will be time for questions and answers after the presentation. This webinar will also be recorded, so contact us after the event if you want to watch it again or to have a presentation. So next I would like just to have read a little disclaimer here, or I'm not going to read everything, but I'm going to say that this presentation is for informational purposes only, and unauthorized reproduction or sharing is not allowed. So with that out of the way, I would like to continue and present today's presenter, Rocco Severino. Over the past 20 years, Rocco Severino has been deep in the trenches of major automotive high-pressure die casting foundry and has first-hand experience utilizing the Uddeholm high-performance solution in order to optimize tooling, increase first-time quality, and improve OEE in a fast-paced die casting environment. We are very excited to have that he has now joined our highly skilled team of experts and can share our solutions with you. Rocco, hello, it's a pleasure to have you here today. How are you?
Hello, Ulf. Very good, thank you.
How's Toronto?
Toronto is cloudy and rainy at the moment.
All right, it sounds like a good day to do webinars about die casting, don't you think?
Absolutely.
All right, so enough of that. I'm sure everyone wants to hear from you, so over to you.
Thank you, Ulf. Much appreciated. And once again, welcome everyone to today's webinar on the Uddeholm high pressure die casting concept, also known as the voestalpine high performance solution. Hopefully you'll be able to take what you see here today and apply it in your daily business with any improvements that you may require. So with that, we'll get started. What is the Uddeholm high performance solution? It is an integrated approach to tool life optimization through the use of premium tool steel, best practice heat treatment methods, PVD coating application, and of course, additive manufacturing technology. A little history before we move forward. So Uddeholm tool steel, as you may know, is more than 350 years old. It remained that way for quite some time before realizing that tool steel is only as good as its heat treatment. So this is where Thermaltech heat treatment was born, and this is located in Ontario, Canada. If you've joined the other webinars by our colleagues, you would have had some insight into what Thermaltech can offer. So it remained this way for many decades, but for the die casting industry, that alone is not enough. Tool steel cannot resolve all issues. So due to that, this is where voestalpine Eifler Coatings was born. This was purchased and added to the portfolio in order to lift the tooling performance and tackle multiple issues at the same time. Then last but not least, you have VAMC, the Additive Manufacturing Center, which complements the other technologies in the system. So what is the system exactly? It's promoted as a complete solution. By complete solution, we mean being able to mitigate or resolve multiple issues at the same time by using various applications and technologies. So this system is comprised of starting with a premium tool steel such as DIVAR. Now the latest DIVAR quality standards can meet a minimum of 18.4 foot-pounds of impact toughness. The NADCA requirement, or the minimum standard, is 8 foot-pounds. So you could see that it's double the NADCA standards, and it really is in a class of its own. So for a foundation in your tooling, it is a perfect option. So we'll see some case studies further on where we utilize DIVAR and PVD coatings as well. So you couple that with best practice heat treatment, obviously to get the most out of your investment. You want to optimize mechanical and thermal properties of your tool steel. This is typically left up to the tool maker. So if you're not following it through and ensuring that a tool steel like a DIVAR is heat treated the way it should be, then you could have issues down the line. DIVAR, for example, cannot be heat treated like your typical premium H13. It has its own recipe. It should be treated as such. So now you move on to surface preparation. This is very often overlooked and also left to a tool shop. Minimum standard for polishing for die casting is typically a 220 stone finish. For many molding areas, that is insufficient. So what we do is we review the tooling and each program, and we increase the level of surface finish for certain areas where we deem necessary. This will eliminate surface roughness, reaction sites, hanging up of the tooling during die opening and or ejection. You follow that with a duplex Tigral process, which includes a plasma nitriding, a layer of about 1 to 2 thousandths, immediately followed by a PVD film. And this is all done in the same chamber. So an oxide layer is not a factor as you would get with many other services where nitriding is done separately from the PVD coating. So with this transition, now you have a substrate hardness of, let's say, 46, 48 Rockwell, followed by a nitride layer, which adds approximately 15 points to that. And let's say that is at 65 Rockwell, and then a PVD film, which is only microns thick, 2/10 for those of you that are imperial. That would add even more hardness to that. It's beyond the Rockwell scale, but you're looking at 3,500 Vickers. So you could see the perfect transition in hardness. Last but not least, again, conformal cooling, which will provide options beyond conventional methods. So it's a nice complement to the system. Why is this necessary? The die casting landscape is changing, and it keeps evolving and rapidly moving towards stricter quality requirements. Quality has always been a key focus for die casting, but even more so now. More aggressive alloys, and all of that just takes a toll on your tooling, results in increased heat checking, shorter overall die life, and of course, you have inefficiencies that are difficult to deal with. So with that, thinking that you could remain with premium H13 and stress tempering, that will no longer be enough in today's die casting. So these demands, what do they mean for a die caster? The part quality challenges faced in die casting on a day-to-day basis are way more than the 6 that are shown on this page, for example. But the 6 that are highlighted here, we have either a product or technology that can positively influence any one of these. And it's important to state that with just voestalpine alone, you can tackle any one of these issues. Now we look at the first one, soldering, for example. For the most part, it is difficult to get away from. That's the chemical attack of the aluminum on the die steel, wanting to pull the iron out of the tool steel. So it's unavoidable for the most part. So when there is soldering, what typically happens in a die casting plant for the die casting plants that still use the die lube lubricant? You typically want to overspray the tool. So trying to resolve soldering, in turn, you're accelerating heat checking. So now you made an investment in a premium tool steel such as Dyvar, and you're trying to resolve one issue, which is soldering, and in turn, you're deteriorating your investment and you're accelerating heat checking. So this is why it's important to have a combination. So a combination of Dyvar and duplex Tigral will allow you to reduce your spray, get the most out of your tool seal, and now you're resolving 2 issues with that combination. If you don't attend to your soldering quick enough, it can result in drag marks. Or if your tool steel cannot withstand the pressures and you have damaged parting lines, you have drag marks during ejection. Erosion and cavitation, same. You need the proper base tool steel, appropriate heat treatment, and a PVD coating if you're looking in front of the gates, for example. That combination is excellent to mitigate erosion. Flash is a result of not having the correct tool steel and heat treatment. And last but not least, shrinkage porosity. If it's heat related, this is where conformal cooling and cooling placement comes into play. And we have a perfect example later on where conformal cooling can help reduce shrinkage porosity due to heat. So all of the part quality challenges, what does that mean? It results in repetitive failures in the die cast machine. So inefficiencies and start and stoppages of your die cast tool and your die cast cell. In this example, you see die cast machine number 4. There have been 44 stoppages over a 1-week period. So some of you may think, well, 44 stoppages, I've seen a lot worse than that. But when you think about it, every time the die cast machine starts and stops, and you need to start up again, typically a die caster will scrap 3, 5, 7 or more castings on startup, all depending on the product and the size of the tool, before being able to make production ready parts. So the downtime now, in turn, promotes a quality problem. So once again, one issue creating another. If you roll that cost over the course of a year, you're looking at millions of dollars just in startup scrap alone, not to mention the toll it's taken on your tooling and or your cell. So premium tool steel, proper heat treatment, PVD coating, of course, conformal cooling is often overlooked, and they all provide significant opportunity for productivity improvement. So repetitive failures, now you know which die cast machines are the worst offenders, but you cannot resolve that. You do not know the reasons for failure, so you cannot determine root cause and corrective action. So you need to understand that first and foremost. In this example, you see for the particular die cast machine, The weekly PM and daily PM on the bottom is more for tracking purposes. This is scheduled downtime. So you look beyond that. You're looking for unscheduled reasons. The first reason is die chip, in turn, welding of the tool steel. That is one of your top reasons, or the top reason for downtime. Followed by polishing of soldering on the tool steel. The one after that, you see die out. That's a single occurrence. So you skip that. It's a one-off. You're looking for repetitive. The next one is broken core pin. So your top three, you now understand and you know, so you can determine the root cause and apply the appropriate corrective action. So now that we know that, tackle one of them, broken core pins. This is usually the low-hanging fruit for a die caster, relatively low cost, and typically easy to change depending on the design, if quick change designs were added to the tooling. So in this example, we have an H13 core at 4446, which typically would need replacement every 4 days. And you can see from the picture, heavy soldering, erosion, and excessive downtime associated with that. So this creates your repetitive failure, your up and down situation, and your unscheduled downtime. By applying proper surface finish to the core pins and the duplex Tigro PVD, the life was tripled. And what that does, it now allows you to schedule replacement during scheduled time. For example, a weekly PM. So now your die cast machine is running when it needs to run, and you're performing maintenance on scheduled time. So you're not affecting your OEE. So this is a perfect start. So now once you have core pins and you've tried that and you have success, naturally you go on to slightly larger inserts. In this example, we have a gasket groove insert for a front cover tool. So you see a little racetrack feature on that tool, as we call it. That is the gasket groove, or creates the gasket groove seal on the front cover, the RTV seal. This here, and it's important to note, was already converted to DIVAR at this point. So the trials were done, the benefits of DIVAR were realized. So this insert was no longer being made out of H13, it was made out of DIVAR, but now we still have breakage at some section of the groove, on average every 8,000 parts. So you may say, well, we have DIVAR, why are we still having breakage? Back to my point that the tool steel does not resolve every issue. And the moment you tell yourself that and you understand that, then you're not expecting the tool steel to do something that it cannot. So here we then apply, again, the proper surface preparation and a duplex Tigro PVD coating. And this tool reached 62,000 shots. And I can safely say from past experience, each insert thereafter with this system would last in the range of 50 to 60,000 shots. So it wasn't a one-off. So why was that successful? This is located on the cover side of the tool. And during die opening, the casting would shrink on the groove and there would be restriction and hang up on that groove. So during die opening, it would want to pull away and eventually break the section over a certain amount of cycles. So being able to release off the cover half helped tremendously in this case. You still need the substrate to be a premium steel like DIVAR to make sure that you can last 62,000 and not have a heat checking concern, for example. You may resolve the breakage, but the last thing you want is heat checking in a groove, which is also unacceptable. And you see the insert on the right here, which is still in the Ontario, Canada office on display. So if it works for sub-inserts, why not work for main cavities? So naturally, this was the test and this was the natural progression. And here you have the same front cover tool, but it is the ejector half, opposite of that gasket groove insert that we just reviewed. So because the larger inserts and you know, everything is about cost, and you have to go through the proper DOE, and you want to make one change at a time, here the main inserts were still Orvar superior at 4446 with the stress tempering. And they would require repair at 28,000 shots roughly. And it was absolutely necessary to repair at 28,000 shots because of the heat checking, soldering, erosion. At the end of the day, the quality of the castings was not maintained. So at that point, you have to swap tools and start fresh. So at 28,000 shots, this tool was pulled. You see a tool life reached of approximately 132,000 shots. There's an asterisk there. So the reason there's an asterisk is you can reach a certain life, you know, barring no catastrophic failure, but how much money and time do you want to invest in order to reach that life? So in this case, to reach 132,000, there was excessive downtime, scrap castings, and of course, repair and maintenance costs associated with that. And the overall quoted die life was not even reached. So you can imagine, if that money was invested up front, it would be better served. As you can see now with the die bar and having that being applied at the beginning, 46, 48 Rockwell, we determined to be the sweet spot, and duplex Tigral coating applied. So I'll take a moment just to discuss when this should be applied. So the tool should be brand new to get the most benefit. When a tool is built, you go through the standard motions of typical polish, 220 stone, for example, and stress temper. The tool is then put into the press for sample, dimensional review, dimensional corrections of the tool. Once the dimensions are PPAP approved or PPAP ready, then the tool is taken apart once again, surface finish brought to the level that is required, and every tool is different, so it needs to be assessed at that time, and then PVD coated with duplex Tigral. Tool is assembled, awaiting customer approval, PPAP approval. Once approved, you hit the ground running, it goes into the die cast machine, and you can see here, it reached 76,000 shots straight. So you may think, well, how's that possible? There must have been maintenance or issues along the way. Well, yes, maintenance in the press was maintained. You still need to do your safety checks, your daily, weekly PMs, check the bolts, check the water lines, minor soldering. You have to perform those checks, no different than checking the air in your tires in your car. That is done, but it's done in the press. So now you're not dealing with setup time, lost setup time, and die changes and cold starts on dies frequently. And it could only reach 76,000 shots if the quality of the castings were maintained. At the end of the day, die caster sells castings, they don't sell dies. So in this case, you could safely say that it was maintained in order to reach that. The customer has adopted and standardized this process since 2013. They do so in order to maintain part quality, reduce scrap, eliminate the repetitive failures, and ultimately achieve quoted rates. That's what it's all about. So the final complement to the system, conformal cooling. Here we have a different product. It's not the front cover product. It's a clutch housing. In this case, it's a multi-plate tool center fill. With a clutch housing, if any of you are familiar with this product, you have thin wall sections, just nature of the design, and right in the center, you're dealing with a thick section. So you need to feed that thick section, but with any thick section in a casting, you also need proper cooling in order to have the right solidification time. So that becomes very challenging. So in this example, with a premium H13 sprue, which fills the casting at 44-46 Rockwell with the duplex Tigral coating. So again, I'm showing you examples of you need the right solution for the problem. There was still heavy soldering and, of course, shrinkage porosity at the gate where the sprue and spreader meet, at the last area to solidify. With that shrinkage porosity, the scrap was well over 20%. I think at one time was close to 30. And you could just imagine you have to backfill and remake those castings, and the whole headache all the way down the line. Tool life was respectable, but the tool life is irrelevant if you're not making good castings. So the only solution, and being able to put cooling where you need it, because you cannot do so with a conventional water line, conformal cooling is the only option. So you could see being able to get the cooling up near that gate allowed the solidification to happen at the right time and reduce the shrinkage porosity after machining, which was exposed previously. It was brought down well below 5%, and a no-brainer, an improvement in temperature. Then that goes without saying. With temperature, if you're putting cooling in a place where you didn't have it before, of course the temperature will be better, but it goes well beyond the temperature. FEA analysis needs to be performed. Do you have the cooling in the right place? So on and so forth. So this was a tremendous improvement and a nice complement to the system. So now back to a die casting plant and scheduling. So a tooling engineer or a tooling supervisor manager needs to schedule preventative maintenance. So with your basic tooling, let's call it, your premium H13 and stress tempering, a typical service regimen would be every 20 to 30,000 shots. You know, every tool is different depending on the product, the size of the tool. The maintenance schedule for a transmission case will be different than one of a front cover, as this example shows, for example. But let's just say for this, it's every 20 to 30,000 shots, and it's absolutely necessary to have a rotation at that interval. Excessive heat checking, frequent polishing, welding, and the biggest waste of all, extra operator rework. So you quote a die cast machine to run with one operator, and now you need to add a body just to bring castings into specification. That is huge waste, and usually the last straw before having a die pulled for another one. With our system, or with the Uddeholm system, you can safely extend that interval to 60,000 shots. You saw that the one case study was beyond 60,000, but you also want to have a schedule that allows you to make a change before going beyond. So 60,000 is a safe number, and with that you are skipping one service essentially. So not only the money saved with one service, but everything associated with that, the schedule, the setup time, the scheduling, the rotation, having more dies ready in order to rotate. So the savings goes beyond just the maintenance interval or the maintenance cost. With this, you have minimal heat checking in front of the gates, minimal polishing, which can be addressed during a weekly PM with just a flap wheel. You have the PVD film protecting that die steel, which allows the soldering, if there is any, to be easily removed. Welding is introduced at the first service interval. And at the end of the day, increased uptime and first-time quality for you, the die caster. All of this translates into an improvement in overall equipment effectiveness, OEE, as everyone calls it in the plant on a day-to-day basis. Many meetings around just OEE in general. So here you have, what is the calculation for OEE? You have availability times performance times quality. This is the calculation to get your overall equipment effectiveness and understand it. So what is availability? If you're scheduled to run 24 hours, the thought is that you are making good parts for 24 hours and you are running. You could see here any time that you are down, essentially downtime, That is lost time. And as I explained earlier, every time you have downtime or you are down, now you have startup scrap. So one issue creating another. So 2 out of the 3 factors for OEE is directly connected to your downtime. So you could see how addressing your repetitive failures, understanding your reasons for failure is critical. In the center, you have performance. That is your cycle time. You're quoted to run at 60 seconds. If you're running at 80 seconds, that is 20 seconds of speed loss. So conformal cooling can help get the solidification where you need it, ultimately reduce your spray, and savings in cycle time on both fronts because of it. All of this translates, once again, increased tool life, eliminating your repetitive failures, higher productivity, improved part quality, and at the end of the day, reduced per part cost for the die caster. First time quality. I want to put some emphasis on first time quality because again, the die caster sells castings and you don't sell dies. First time quality, what is that? It's a lean metric, which is essentially manufacturing parts correctly the first time without the need for inspection, rework, or replacement. All the non-value added cost associated with that. What does that mean? Quality is built in. It's built into the casting, and in order for it to be built into the casting, quality needs to be built into the tooling up front. Make your investment up front, and everything downstream, down the line, will be taken care of. Make your life much easier. This is a mindset that Uddeholm and Voestalpine has embraced. We believe in quality being built into the tooling. And that is why premium grades such as Divar exists. And that is why a premium coating such as Duplex Tigral exists in order to allow you to have the quality built into your tooling. What does this mean for you, the die caster? What are the top 3 benefits of this system? Consistency, reliability, and accountability. These are the top 3 benefits, and they cannot be more important for you. Consistency, what is that? If each tool is built with Uddeholm material and Voestalpine value-added technologies, this will result in repeatable performance throughout all cavities, essentially eliminating variables. Personally, and from personal experience, there's nothing worse than having multiple tools for one product being built differently. For example, one with Uddeholm tool steel, one with another, one with coating, one with stress temper. When there is an issue with that tool or die cast cell, trying to pinpoint the root cause can be daunting and sometimes impossible. So you're basically guessing at best at what the reason could be. Since we adopted the consistency and having each tool built the same, that allowed us to focus on a different avenue, whether it be the process, whether it be the machine itself. You have one constant that you can deal with. That is why it's important. Reliability. Your tooling needs to be reliable. How can it be? It can be by utilizing the strength of our organization's technologies in order to assist you in achieving targets. How can you do that? Quality needs to be built into the tooling. That is the only way. If you expect quality out of the castings, then you need quality in your tooling. Last but not least, accountability. Accountability is key. Every business depends on it and could only survive if everyone is held accountable, and that goes the same with suppliers and vendors. You can only do that if you have one technology source which will allow for ownership and of performance and will instill confidence in your tooling and organization. I'm sure some of you have sat across a table staring at a cracked tool in your careers, and it's never pretty. You have a steel supplier blaming a heat treater, you have a heat treater blaming the tool maker, and the tool maker blaming the production facility or process. Nothing gets resolved, and you're left with a cracked tool that you cannot use. So partnering with someone eliminates that from the equation, and you have full accountability. So once again, consistency, reliability, accountability. That's very important. And with that, we go to Q&A, and I'll pass it over to you, Ulf. Thank you, everyone.
Thank you very much, Rocco. If you have to leave now, we have recorded this webinar, so contact us after the event if you want the recording and/or the presentation. So we will now take questions, and we will keep this meeting open until they have answered all of them. So let's take a look here. We do have one question here. Conformal cooling by 3D printing using heat wire or other powder. What do you think about that, Rocco?
I'm just reading that. Sorry, Ulf. 1 second. Question. What do I think about that? Well, once a premium powder is developed, I think it will be excellent for the market. Right now, our mills are heavily involved in R&D and working on such powders. Right now in the market, and with other facilities as well that perform 3D printing and conformal cooling, the standard is margin steel with an H13 hybrid and or full print. There are some that claim to print H13 as part of the solution, but you can see, or you can understand the difficulty in having H13 as a powder. And if it was that easy, then everyone would have adopted it by now. But there are things in the works from our mills, and in the near future, and looking forward to having something that can be a premium powder, for example, similar to a Divar. The margin steel in H13 does work, and it will resolve your issues. So just like your typical tool steel, there should be different levels as well. It's not necessary to go to the best powder out there for everything. Hopefully that answers your question, but I do see the need for it, and I do see the benefit.
Okay, here we have a question. Increased hardness will have a reduced toughness. Then how come Tegral coatings reduce heat checks? So now we're moving into the area of metallurgy.
Right. That's the beauty of Divar. With the increased hardness, you do not reduce toughness as you would with a premium H13. And if you've joined, if you attended Richard Oliver's presentation, I believe he walks through that. And it's a nice pictorial on how the new standard of Divar maintains high toughness at higher hardness. That said, the second part, how come Tegral coating reduce heat checking? It's the base steel that does the most work for reducing heat checking, and this is where the combination is beautiful. The duplex Tegral is basically a barrier and prolongs the heat checking from surfacing, but it is your substrate that is doing all the work. So even though Divar, for example, can be heat treated at 4850, it is not necessary when you apply a PVD coating. So now you have your perfect transition, as I described earlier, where you have the right substrate hardness, and then you have your transition in hardness thereafter with the nitriding and the coating. That's important because, from my experience, prior to PVD coating, we would nitride tools and we would apply a 2 to 4 thou case or 4 to 6, and then say, well, let's go harder and harder and harder in order to get better life. all that did was make the tool more brittle and result in catastrophic failures and cracks. And the reason being, most die-cast machines, and I'm not going to speak for all die-casting plants because there are some excellent ones out there that maintain their die-cast machines regularly. But for the ones that I was involved with and familiar with, you would have concave platens, which in turn increases deflection in your tooling. So you can imagine, the harder the tool, the repetitive deflection, inevitably you will have a cracked tool. So to answer your question, with the die bar, increase in hardness does not affect your toughness to the levels that you would see with a standard premium H13, and you don't need to go extremely hard in your substrate when you apply a coating such as duplex Tigro. Good question.
Yeah, you mentioned Richard Oliver, and he's actually next up at in 1.5 hours. So, and then we're going to finish the day with Sami Arason about additive manufacturing for high pressure die casting. So visit the uddeholm.com/US website and look under the event section, and you will find links to sign up if you're interested. We received another question here about what is the special feature of duplex Tigral compared to other coatings, and can it be used for die cavity and not only corpions?
100%. It can be used. I'll answer that first. It can be used for, as you saw in the case studies, that was a complete main insert. And they still PVD coat all of their new tooling as long as it fits the envelope of the PVD chamber. And because of the success, just one note, and whenever a new tool was designed, the thought process was always, how do we design this so it can fit in the PVD chamber? You know, that's the level that we got to and the plant got to. So yes, it can be more than just corpins, definitely. And now the main difference or benefit, I alluded to it earlier, when with the Eifler Vacotec system, the nitride diffusion and the PVD coating is done in the same chamber, in situ as they call it. Other coaters, and I've used them in the past, they'll nitride in a nitriding furnace first. Once it's removed from the furnace and it's exposed to atmosphere, now you have an oxide layer on that tool. If that layer is not removed, now you have the risk of adhesion issues when you put it into the PVD chamber for coating. That is a common problem, and I've experienced it myself, which results in inconsistency. Back to the top 3 benefits. Consistency is key. So I've used others in the past in my career, and when they got it right, it was good. But it has to be consistent. So the main difference is the consistency with the Eifler Vacotec coating, the duplex Tigro. Hopefully that answers your question. Another good question.
All right, let's keep typing in. Okay, we got another one. After using coatings for cavity, can groove cracking be reduced or increased?
If you're using coatings for cavities, can groove cracking be reduced or increased? Now, by cracking, I'm assuming we're talking heat checking. I'll go down that path, not groove breakage, but let's say it's heat checking. You would still need a combination of the right tool steel with the coatings, right? As I explained, the coatings is not your primary defense for heat checking. So you can't think, I'm going to go cheap on the steel, put a nice shiny coating on it, and my problems will be resolved. You cannot have that mindset. You have to start with your substrate and then apply your coating. That is critical. Your substrate, proper heat treat, coating, combination. Can it be, if you do have that combination, can it be reduced Can heat checking be reduced? Absolutely. But if you're talking cracking as in catastrophic cracking, that would only be the case if you are too brittle. The coating is such a small film, so even at that high hardness, will not increase your chance of catastrophic failure. It won't do that.
Then
Great questions. Excellent.
Yeah, they have a question here from a colleague also overseas. They have an ABP machine. So which additional process is better, nitriding or oxidation, or Tigral with or without ABP?
The ABP, I'm familiar with that, and hello to a fellow colleague. And that in combination, so if I won't go back in the presentation, but if you remember the one slide with the complete solution and we went through the motions, in the position where we say the nitride diffusion, for example, you can insert ABP in that process before the duplex Tigral. That in combination will work really well, and I believe we have some success stories with that. Nitriding with oxidization, we have the ABP process, we have Thermonite 2 process, which we do perform when we repair tools with the duplex Tigral. So during our repairs, and we work well with Thermaltech for this, the coating, more than 80% of the coating will be intact. So it does not make sense to strip and recoat the tool at that point. So we apply as you mentioned it in your question, a nitriding and with oxidization. That would be our Thermonite 2 process. That protects the repaired areas, and the coating areas that were not affected remain intact. So now, again, you have the right solution at that point in time for your tool at that tool life. So yes, the ABP, if you have that as an option, would fit nicely before the duplex Tigral. But it does not replace the duplex Tigral. Let's be clear. They're totally different. If someone says to you, I have an equivalent to duplex Tigral, if it is not a PVD coating, it is not equivalent. If it's not done in the Vacotech chamber, then it's not equivalent. So the important thing with solutions, do not try to implement something to make up for something else. No different than trying to resolve soldering and accelerating heat checking. Great question.
All right, let's take the next one here. If an insert is PVD coated with duplex Tigral, how does the tool get prepared for welding and refurbishment? And do you reapply the coating after the repair?
Oh, great question. Yeah, that I touched on it answering the previous question, and the answer is depending on the size of the insert. So if you were repairing a main cavity like the front cover tool, you would proceed with the process as I described just now. You would repair the areas that require it, for example, in front of the gates. After weld repair, you would apply Thermonite 2, so which is basically a nitriding with an oxide layer. And that would protect the repaired areas, and you keep the remaining coating intact and get the most out of it. If your insert is smaller, then economically it would make sense to strip it and recoat it, repolish and recoat it. You're going to get better performance out of the PVD, the duplex Tigral. Let's be clear. But some protection is better than nothing. A stress temper, if I wouldn't even really call that protection. That's more for die loop, but it's essentially not really a protection layer for your tool. After initial shots, the stress tempering really is gone, the oxide layer. But another great question.
Then we have an AM question here. In a 3D printed insert, the conformal cooling circuit is typically very close to the molding area. How do you determine if it's too close or if there is a potential risk for cracking?
Very good question. So the only way to determine if a conformal cooling line, or to properly determine if a conformal cooling line is too close to the molding area, is with data, and that's engineering backing. That's the only way. Many additive manufacturing shops out there will just provide a concept, conformal cooling concept, and some temperatures. So you provide the thermal imaging of your existing tool. They take that, they design conformal cooling around it, will show you the improvement in cooling, and you go from there. With VAMC, or the way we approach conformal cooling, there is always an FEA that's done to back the design. And that's the only way to do it. It's no different than a conventional tool pre-launch. You need to perform your simulations, your thermal studies, your water line placement. Do you have deflection? Do you have stress areas? It should be approached the same way. And that's the only way we approach it. You have to back the design with an FEA in order to determine if it's too close to the surface, if the stress is beyond what the tool can handle, and if it is, you redesign and you rerun the simulation.
Okay, a follow-up question here about ABP. Should ABP be done after plasma nitriding or before plasma nitriding in duplex treatment? Maybe we should ask Jerry.
Once again, so say that again. So should the ABP be applied
after plasma nitriding or before plasma nitriding in duplex treatment?
It would have to be before. That the duplex treatment is always the final treatment. The tool needs to be properly prepared, extremely clean. You wouldn't want to shot peen a surface that is PVD coated, for example. That's PVD is always the last stage in the tooling.
Okay, and here, so what benefits do you provide compared to other steel coating and additive manufacturing suppliers? So why choose you?
At the end of the day, it goes back to the last slide. It's consistency, reliability, and accountability, all from one organization. That's you can't say that for others, and I have personal experience with that. Being in a die-cast foundry for 20 plus years, there are many issues, production issues. You wake up in the morning, you have 20 priorities, and you woke up to 50 more to deal with. So if there is a partner that can make your life easier and take something off your plate, why wouldn't you utilize them, especially with the quality of technologies and products that can be offered? It's a one-stop shop, really, and partnership is the only way to go when it comes to tooling. You do not want finger pointing and you're left with tools that do not perform. That is the main reason to go with voestalpine for sure.
Okay, now we had one more coming in here. What should be the minimum thickness between conformal cooling and die surface? I think that depends on the design and.
Yes, this would again go back to engineering. Everything has a rule of thumb, let's call it. With standard water lines for die casting, you're looking at what's the rule of thumb is 3/4 of an inch minimum distance for a bubbler, a cascade. That is the rule of thumb that everyone follows, but it's just a starting point. It doesn't mean you cannot go closer, and it doesn't mean you should not go further in some cases, depending on what's happening during fill with that tool. So the only way is with the backing of an FEA and engineering. That's the only way to answer that question properly. Anything else would be a guess, a starting point, which is fine. You could design it based on, double the size of the conformal line, for example, as a starting point. But once you perform your study, any issues or any stresses that you see should be addressed.
So basically, contact Uddeholm or voestalpine additive manufacturing centers.
100%.
And start a discussion.
Us, and we can definitely walk you through that and make sure that it's proper. The last thing you want to do is try conformal cooling for the first time and not have the most optimal design as a trial. It just gives, first impression is everything. So you want the right design in order for you to perform your first trial and have success. That's the goal.
All right. So don't see anything else. So let's wrap this up. Thank you, Rocco, and thank you all for attending this webinar. If you wish to reach Rocco or an Uddeholm representative, please visit our website, www.uddeholm.com, for worldwide contacts, or call us in the United States and Canada on 1-800-638-2520, or in Mexico on 52-442-689-5900. There will be a short questionnaire when we close and also in the follow-up email, and you can rate us if you enjoyed this, and there you can also let us know if you want to be contacted to discuss Uddeholm high performance solutions further. This webinar was recorded, and we have and contact us after the event if you want to gain access to it. With that, I wish you all a good rest of the day, or a good morning, or a good evening, wherever you are. Thank you and goodbye.